Max here again, welcome back to the shop. So this episode we're going to make a clutch hub. So this is what we're going to reproduce out of steel as per the original plan. So I'll just have a crack at welding this crap because we weren't sure what it was. We had a bit of an inkling it was die cast. I suppose could be a bit of a giveaway when you're in the moulding. You see these circles here? It's a bit of an indicator, maybe. So it turns out it is die cast. So when we tried to weld it, this like absolute shit. All it wants to do is make holes. So, these are 2 bits of steel here will be the victims. We don't have a piece of steel large enough to get this out of one piece, which is no problem, as this part here will form the centre part, and this disc will form the outside. So we'll get the disc board out, we'll get this turned down, push them together, we'll run a weld around on both sides, and then we'll have something solid to work with to produce the hub. So this is all pretty well all 4-jaw work, this job. As we don't want to be holding these old parts in a 3-jaw. Right, we'll select an appropriate tool and some appropriate feeds. See, this tool here will probably be alright. And we'll start chomping a bit off the outside. Okay, we have this side all roughed out, so this part here will form this recess here. So what we do now is we put our shaft in, turn our shaft down so it's a press fit in here, and then we'll flip the part over and rough out the features on the other side. Before we forget, we'll just do a little bevel on here for a weld prep. Okay, I think that should be enough. So we'll flip our jaws around and we'll get the other part set up, and we'll just take a light skim off the diameter for a press fit in the bore here. Okay. Right, we'll get a tool set up and we'll turn this OD down till it's a press fit in our hub. Okay, I've just done a quick facing cut. I've got about 60 thou to come off before we really got to start measuring. This is a totally unknown material, and the way it took that facing cut, she's been heat treated, God knows what it is, but it's not overly hard, so you can still mark it easily with a file. So anyway, we'll rip 60 thou off the OD and then we'll get some measurements happening. Yeah, I was just watching, I'm part way through watching Doug Lester's video at the moment, Dougie from Metalworks Machine Shop, and he's turning down a bit of tool steel. And yeah, he's just experimenting with a few depths, trying not to get the spaghetti, or the noodles as he calls them. That on a light cut, whatever you're going to do, you're never going to break a chip unless you've got, maybe for your last cut you change your tool holder to one off a very small lathe with a tiny nose radius. So unless you're down the side of your insert you have a chip breaker and your nose radius, and unless you're well into that chip breaker there ain't no way you're going to break a chip. So. Okay, we need to get a proper dimension of this bore so we know how big to turn our spigot to. Okay, so we are 2 inches, 238.5. So that's 2 inches, 238.5. So if we add, say, 2.5 thou interference, that'll give us 2 inches 241. So yeah, 2 inches 241, that's what we'll turn this piece of material down to in the lathe. Okay, we'll see how we're going for size. We're just about there. Okay, we are 2.2415 there, so just half a thou up there. Down here 2.244, so 2.5 thou taper. We'll let that go, and I think what we'll do is we'll rough out some of the features in this bore here. We'll take the bulk of that out. We'll get an undersized hole drilled through the core of it there, and then we'll just come back and just take the last thou that we need to off this OD. So I'll get a centre drill in there. Okay, that's where we need to be. Okay, our finished bore that we have to take to is 5/8 of an inch to fit the motor shaft. So a 1732 drill bit we'll put through, and that'll leave us in the vicinity of 100 thou to take out once it's all welded in situ. Okay, now I've got to get in there with a bar and just work that front face and square all that off at the end there. Okay, that's all we need for now. I'll just break this edge here on the front. Okay. Okay, we have a finished diameter on the outside of here of 52 millimeters for 22 mil deep, so say we go 20 mil deep. So we can take 4 mil off that, 20 mil deep. And that's this half of the bar complete.